Hello everyone. Sample questions based on time and work. Question number 386 to 400. 12 men can do a piece of work in 30 days. How many more men will be required to do it in 20 days? Obviously, we can do this sum in 2 to 3 seconds, but let me revise the concepts first. When we have men, time, let me write time in the way dates and hours. So relationship between men and time is simply given by MDH masala formula. Famous MDH formula. M1 D1 H1 equals M2 D2 H2, where D and H are symbols used for time. D stands for days, H stands for hours. Number 1. Number 2. If work done is not the same, if work done is also different by different group of people, what we'll do? We'll just divide the first format on both sides by W, that is the work to be done. And hence this becomes the second concept or second formula which we can use. Now the basic assumption underlying these first two formula is that this group 1 men and this group 2 men have same efficiency, but practically different group of people have different set of efficiency. So now the advanced version would be multiplying this both side by the efficiency of the men group. Men group means worker group. It might include men, women, children, skilled, unskilled, semi-skilled, anything. So the first basic 3 formats which depicts the relationship between men, work and time is MDH masala formula. Based on this, let us see how quickly we can do this sum. 12 men can do a piece of work in 30 days. 12 into 30. Hours are not given. How many more men will be required? Let me require X men, so that the work is completed in 20 days. So what is the value of X? 12 into 30 by 20. That is 18. I have 12 men, but I require 18 men if I want to complete this work in 20 days. Extra men required or extra labor required would be 18 minus 12, that is 6. Option C fits in. 8 men or 15 women earn 12,000 rupees per month. Means the earning of 8 men is 12,000 and earning of 15 women is also 12,000. Now how much will 20 men and 24 women earns in 5 days? So actually the earning is 12,000 in 30 days. So if I need to convert this into 5 days, it would be 2,000 rupees. That means 8 men earns 2,000 rupees in 5 days. So it's a simple unitary method. How much will 20 men earn? 20 men will earn 2,000 by 8 into 20. 4 times 5, 4 times 2, 2 times 1,000, that is 5,000. So earning of 20 men in 5 days would be rupees 5,000. Similarly, 15 women earns 2,000 rupees in 5 days. So 24 women would be earning at the same efficiency. Obviously that is underlying assumption in this question. 2,000 by 15 into 24, 3 times 8, 3 times 5, 5 times 400, that will give us 3200 rupees. So total earning of 20 men and 24 women in 5 days with the same efficiency level is 5000 plus 3200, that is rupees 8200. Option A fits in. A farm having 5000 hens has provision for 250 days. This is M and this is D. M into D. How many hens must be sold after 50 days? That means till 50 days, 5000 hens have enjoyed the provision. So I can say the total provision equals 5000 hens enjoying it for 50 days, and now X number of hens enjoying the remaining provisions for how many days? 250 more days. That means 250 days. We just need to find the value of X, that how many hens now can enjoy the remaining provision for 250 more days over 50 days. So 5000 into 250 minus 5000 into 50 will give us 5000 into 200 divided by 250 will give us number of hens. 250 is 20 times, that is 4000. So 4000 hens, if they are, they can enjoy the remaining provisions, that is food, given that each hen eats the same quantity of food every day. That's an underlying assumption. So 4000 hen can enjoy it for 250 days. Now the question is, how many hens must be sold? That farm should sell 5000 minus 4000, that is 1000 hens by the end of 50th day. Answer B fits in. 50 men can do a piece of work in 12 days. 50 men, 12 days, working 8 hours a day. How many hours a day would 60 men have to work in order to do another piece of work twice as great? If I take the first piece's work as 1, another piece of work as 2 units, in 16 days, bingo, we have our setup with masala formula. M1D1H1 equals M2D2H2. 8, 16, 2 cancel, 0 gone, 2. H2 equals 5 into 2, that is 10 hours. They need to work 10 hours per day. Option C fits in, and masala is always hit. A contractor undertook to finish a road 12 km long, means that is the work, in 350 days time, but after employing 45 men, employment for 200 days. Okay, they have worked for 200 days. He found that only 4.5 kilometer of work were completed. Only 4.5 kilometer of work was done by 45 men in 200 days. How many additional men must be engaged to finish the work in the given time? That means we need to find how many men would be required to finish. The remaining work is 12 minus 4.5, that is 7.5 kilometer, and the remaining time available with us is 350 minus 200, that is 150 days. Based on the efficiency of these people who have worked for 200 days, we need to identify how many people now can complete the remaining work in 150 days. So now we use masala. M1 D1 by W1 equals M2 D2 by W2. Because hours are not given, so those are assumed to be same in both the case. So 45 men working 200 days completed 4.5 kilometers. How many men would be required working for 150 days and completing 7.5? So 4.5 10 times, 7.5 20 times, and if I cancel this with 10, so M2 is 100 men. 100 men would be required to complete the remaining tasks in remaining time. Now what is the question? How many additional men are required? We already have 45 men with us. Additional workforce required is 100 minus 45, that is 55 men. 55 new men need to be employed so that work is completed on time. Option D fits in. Mohan can do a piece of work in 10 days and Ramesh can do the same piece of work in 15 days. How long will they take if both are working together? And if two people work time is given, A completes the work in X days, and if B completes the same work in Y days, and if they choose to work together, then they would be completing the work in 1 upon 1 by X plus 1 by Y days. That on solving we get xy upon x plus y, and the formula looks like product by sum. Product of the time taken by the two people divided by the sum. So in our case, A, that is Mohan, is taking 10 days and Ramesh is taking 15 days. So the work would be completed in 10 into 15 by 10 plus 15. 150 by 25, that is 6 days. Option A fits in. Mohan can do a piece of work in 10 days. Ramesh can do the same work in 15 days. If Suresh, who can finish the same work in 30 days, joins them, how long will they take to complete the work? Now this time, 3 people are working together. If 3 people are working together, time taken would be 1 upon 1 by x plus 1 by y plus 1 by z. On solving, we'll get xyz upon xy plus yz plus zx. That means product divided by sum taken 2 at a time. But this formula is actually time consuming and it will actually consume time. So we have the best process to solve these kind of problem, and that is simply the CM rule. Rule number 8 from my rule book of arithmetic. CM rule, and believe me, this rule rules time and work. Now see how quickly we can do this. Just find a common multiple of 30, 15 and 10. Not necessarily LCM, just any common multiple, and the first common multiple which I can visualize is 30. 30 by 10. You won't be writing this when you would be solving. I'm just writing so that these things you can learn first slowly and then you can practice it, which will enhance your speed. 30 divided by 10 is 3. Then 30 divided by 15 is 2. 30 divided by 30 is 1. Since we need to add these 3, just add these 3. 3 plus 2 plus 1 is 6. Total time taken by these 3 people working together is this CM. 30 divided by whatever you get here, 6. That is 5 days. If you practice, in no time you would be able to solve questions and many typical questions using CM rule. So option B fits in. A can do a piece of work in 6 days. B takes 8 days to complete it. C takes as long as A and B would have taken working together. So let's first find how much time is taken up by A plus B working together. Product 48 by sum 14, that is 24 by 7 days. So that is the time taken by C. Now how long will it take B and C to complete the work? Now B 8 and C 24 by 7 are working. Product 8 into 24 by 7 divided by sum 8 plus 24 by 7. That is 8 into 24 by 8 into 7 is 56 plus 24 is 80, 10, 12 by 5. So they will require 12 by 5 days to complete the work. Time taken up by B and C together is 12 by 5 days. Now, can we use RCM rule and cut down these calculations? Let's check. A6, B8. Perfect CM for 6 and 8. 3, 4, 12 into 2, 24. 24 by 6 is 4. 24 by 8 is 3. Now, C work is 4 plus 3, that is 7. Now, I need how much time is taken up by B and C? B and C is 3 plus 7, that is 10. Bingo. B plus C will take 24 by 10, that is 12 by 5 days to complete this work. 2 seconds, option A fits in. 12 men or 15 women can reap a field in 14 days. 12 men can complete the work in 14 days. Similarly, 15 women can also complete the work in 14 days. Find the number of days that 7 men and 5 women. Now 7 men would be completing this work in 14 into 12 by 7, that is 24 days. And 5 women would be completing this work in 14 into 15 by 5, inverse unitary method, that is 42 days. Now, if we are adding these two group of people, 7M and 5W, so we need to just use our addition rule. And addition rule is simply product by sum for two people. So it would be 24 into 42 by 24 plus 42. That is 66. 6 times 11, 6 times 7. So 140, 168 by 11 days. Option C fits in. A team of 30 men is supposed to do a work in 38 days. After 25 days, 5 more men were employed. Okay, so after 25 days, we have 30 plus 5, that is 35 men working on the project. And the work was finished 1 day earlier. 1 day earlier means now these 35 men have only worked for 38 minus 25, that is 13, and they have finished 1 day earlier. That means they have worked only for 12 days. These 35 men would complete the remaining work in 12 days. If these 35 men, how many days would it have been delayed if 5 more men were not employed? If these 35 men are not working, only 30 men are working, then how much time they will take to complete the remaining work? So here we would be applying our masala formula on remaining work. Remaining work could be completed by 30 men in suppose D days, and the remaining work is completed by 35 men in 12 days. So D is 35 into 12 by 30. 3 times 7, 3 times 6, 6 times 2. That is 14 days. So if there is no reinforcement of 5 new people, the remaining work would have been completed in 14 days. Now, so total time taken would be 25 plus 14, that is 39 days. But they have got only 38 days. So, without reinforcement, work would have been delayed by 1 day. How many days would it have been delayed if 5 more men were not employed? Delay is of 1 day. Option B fits in. A can do a work in 25 days and B can do the same work in 20 days. They work together for 5 days and then A goes away. In how many days will B finish the remaining work? We can very easily use 1 day format. If I say A can complete a piece of work in X days, that means in 1 day A completes 1 by X part of the work. That is known as fraction of the work. Since A worked for 5 days, so work completed by A is 5 by 25 and B works for 5 days plus X more days. So work completed by B in X plus 5 days is X plus 5 divided by 20. Now the total work done in fraction is always taken as 1. That means 5 by 25 plus X plus 5 by 20 should be equals to 1. This is 1 by 5. I deduct it from this end. 4 by 5. Then 5 goes out with 4. X plus 5 is 4 into 4, 16. X equals to 11 days. In how many days will B finish the remaining work? Answer is 11 days. Now, can we use our CM method to do this? Let's see. A 25, B 20. First thing hits in my mind is 100. Let's 100 units is the work to be done. 100 by 25 is 4. 100 by 20 is 5. A works for 5 days, completed 20 units. That means B need to complete 100 minus 20, that is 80. 80 by 5 is 16. B already worked for 5 days. More days required by B are 11 days. Answer. Option B fits in. A and B working separately can do a work in 9 and 12 days respectively. A will take 9 days, and if B is working alone, he will take 12 days to complete the work. A starts the work and they work on alternate days. Peculiar ADW type of sum, alternative days work sum. And see the strength of CM method in understanding how quickly we can find answer for ADs or alternative days work sum. In how many days will the work be completed? Now listen to the story. Find the CM for 9 and 12. 36. The first number which hits me is 36. Let they need to produce 36 units. That is the work they need to do. Now A can complete 36 units in 9 days. That means A's working rate is 36 by 9. That is 4 units per day. Now if B is producing these 36 units alone, he will take 12 days. So his working rate is 36 by 12, that is 3 units per day. Now what is the scene in alternative days work? Since the day is starting with A, I'm writing A and B. A will work for a day, he will produce 4 units. Then B will come the next day and he will produce 3 units. And I will keep on writing 4 3 4 3 4 3 4 3 4 3 4 3 4 3. And now the cumulative addition, and the point where 36 units cumulated ends, that would be the point our answer would be. 4 plus 3 7, 14, 21, 28, 35. Now here 35 units over, done. Now only 1 units remain to be produced. And who will produce this 1 unit? Mr. A will produce this 1 unit. In what time? Mr. A produces 4 units in a day. So to produce 1 unit, Mr. A would require 1/4 of the day, that is 0.25 of the day. Now we can count the number of days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10.25. Work would be completed in 10.25 days. CM rules. Rule number 8 from our rule book of arithmetic. 10.25, option A fits in. ABC can do a piece of work in 16 days, 64 by 5 days and 32 days. 16, 64 by 5 and 32. They started the work together. Wonderful. But after 4 days, A left. That means A worked for 4 days. B left the work 3 days before the completion. And who completed it till the end? Obviously C, because nothing is mentioned about C. Let C worked for X days, if X is the completion time. B left the work 3 days before the completion. B left the work 3 days before completion. Wonderful. Now, we can use our traditional method of fractions, and work done by A in 4 days is 4 by 16. Work done by B in X minus 3 days is X minus 3 by 64 by 5. And work done by C in X days is X by 32, and that should be equals to 1. Let's solve for X. Nine days. X equals to 9 days. In how many days was the work completed? Work was completed in 9 days. Now shall we try with the CM method? Are we ready for that? CM 64. 64 by 16, 4. 64 by 64 divided by 5, 5. 64 by 32, 2. Now look carefully. A works for 4 days. That means work done by A is 16 units. Deduct it. B works for X days, but he left 3 days before completion. 5 into minus 3 is minus 15. Add up. 64 minus 16 plus 15 is 63. Now at the end, we are left with 5 and 2 only. Why? Because A's work is already adjusted completely. 5 plus 2 is 7. 63 by 7 is 9 days. 2 men and 7 boys can do a piece of work in 14 days. 3 men and 8 boys can do the same piece of work in 11 days. So we have end data available with us. And now they have asked in how many days 8 women and 6 boys would be completing this work, but 3 times the work. Okay, so we have end, and the question is also asked in end. That's why I called it end cube rule or 3 end rule. How to use this 3 end rule is, let us convert this group size into 1 day format. Suppose this is group 1. Group 1 can complete the work in 14 days. That means if they want to complete this work in 1 day, how many such groups of people are required? 14 such group of people would be required to complete the work in 1 day. Similarly, 11 of such group of people would be required to complete the work in 1 day. Now, 1 day work of 14 times this group is equals to 1 day work of 11 times this group. Let's simplify this and quickly find the relationship or the efficiency between men and boys. Oh, sorry, they were women and boys. So we have 1 women work is same as 2 boys work. Now we can use any of this equation. Let me use the first one. 2 women plus 7 boys can complete the work in 14 days. 2 women means 2 boys into 2, that is 4 boys plus 7 boys. So what I have is 11 boys can complete the work in 14 days. Now 8 women plus 6 boys means 8 into 2, 16 boys plus 6 boys, 22 boys. So I know that 11 boys would complete the piece of work in 14 days. Then 22 boys would complete the 3 times work in how many days? 2, 7. D2 equals 7 into 3 is 21 days. Answer. To do a piece of work, Vimal takes 3 times as long as A and C together, and C takes twice as long as A and B together. If the 3 together can complete the work in 10 days, how long would each take by himself? A concept to be learned first. Suppose A takes P times what B and C takes to complete the work. B takes Q times the time taken by A and C to complete the work, and C takes R times the time which is taken by A and B to complete the work. And suppose they all 3 working together takes X days to complete the work. Then individual time taken by A would be P plus 1 into X days, B Q plus 1 into X, and C is R plus 1 into X days. If we know this format, this question is 5-second question. If the 3 together can complete the work in 10 days, means here X is equals to 10. B takes 3 times as long as A and C. Individual time taken by B would be 3 plus 1 into 10, that is 40 days. Chandan or C takes twice as long as A and B. That means C, Chandan will take 2 plus 1 into 10, that is 30 days. Now, what is available with us? and see the power of CM now. ABC takes 10 days, B alone takes 40 days, C alone takes 30 days. Now tell me, if I need to find the value of A, from ABC I need to deduct B, I need to deduct C so that I can get A, isn't it? CM for 143 is 120. 120 by 10, 12. 120 by minus 40 is minus 3. 120 by minus 30 is minus 4. 12 minus 7 is 5. Time taken by A is 120 by 5, that is 24 days. CM rules also works with negative quantities. During subtraction also we can use CM. As said, CM rule rules. So the individual time taken is A 24, B 40 and C 30. Answer. Thank you for participating, and on this note, I'm Mohit Jain signing off from MJ's Maths and Stats. That's MJ Magic Studio to you. Telegram number and email ID is there on your screen. Feel free to talk to us and practice more. Best wishes, do well. Thank you.